Good morning, everyone. Thank you for the very generous introduction. It's truly an honor to be here meeting all of you in this amazing department. Before I dive into today's topic, I just wanted to show you a quick snapshot of where I am coming from. The beautiful University of Minnesota. And yes, this is exactly what Minnesota looks like all the time. All those rumors you may have heard about endless snow, freezing temperature, or people needing snowmobiles to get around are not correct. Like Jimenez? You agree with that, right, Jimenez? But seriously, I'm excited to be here to talk about some of the most important development in the perioperative pain management and their impact in clinical practice. I have no relevant financial or non-financial relationship to disclose related to this presentation. And here you see some familiar sightseeing landmark. The Eiffel Tower, Statue of Liberty, Burj Khalifa, and Taj Mahal. And you might be thinking, oh, this is turning into a grand round of the next vacation, but unfortunately it is not. These landmarks have no relationship with the content of my talk. They just represent the four major areas we will be exploring this morning, four key topics in perioperative pain management research that I believe will have some impact in our clinical practice in the next few years. And all right, here's a picture that I believe we all can recognize, right? This is Taj Mahal. It's located in India and was built by Emperor Shah Jahan way back in 17th century. It took 20 years, 20,000 people, and I am guessing a construction budget that will, even today, will make all of us sweat. It's made entirely of white marble. Yes, no shortcuts, just pure marble. Now, the romantic story goes that Shah Jahan built it as his great symbol of love for his wife Mumtaz. And the name Taj Mahal comes from Mumtaz. Mumtaz Mahal, Taj Mahal. Very sweet, right? But people who were not such a big fan of Shah Jahan like to say that there is no love here. He just wanted to glorify himself because he did have several other wives. Whatever the real story is, Taj Mahal stands as one of the greatest landmarks in history. And today, under the backdrop of this romantic, iconic symbol, we'll talk about another landmark, a study that shaken the field of regional anesthesia with lawsuit, stock market crash, and a lot of other dramas. The study is perineural liposomal bupivacaine is not superior to non-liposomal bupivacaine for peripheral nerve block analgesia. It was published in Anesthesiology in 2021. So No love story here, just cold and hard evidence. Liposomal bupivacaine is very different than other local analgesic. It is designed to deliver controlled levels of bupivacaine. It is composed of naturally occurring biocompatible lipids. It encapsulates the bupivacaine molecule in a suspension of multivesicular liposome, which releases over time and achieves greater analgesia at the surgical site and provides safe and consistent level of the bupivacaine. Up to this point, company is right, correct. There's no concern here. But they also claim that this liposomal bupivacaine eliminates the need for catheter and pumps that may hinder recovery of the patient, which they did not show any evidence. They also claim it extends analgesic duration while reducing the need for the opioid. This claim is without any evidence. So these areas need further investigation. So this important study was published by Hussain and colleagues, and it's worth highlighting that Nasir Hussain was a CA3 resident when at the time this work was published. And I think that's pretty impressive. CA3 resident did a meta-analysis and published in anesthesiology journal. We don't see this very often. So the primary outcome of this study, they looked at the difference in 24 to 47 hours, area under the curve, pain score, severity. They included 9 randomized controlled trials in this analysis and found that statistically but not clinically significant differences between liposomal bupivacaine and non-liposomal bupivacaine. Okay? And now here it gets more interesting. And here's the 9 trial, right? When they removed one trial that was industry funded, they found absolutely no difference in pain score, opioid consumption, time to the first analgesic, or patient satisfaction. Now at this point you might be thinking, wait a second, why did they remove one trial? Why you cherry pick the articles? What's wrong with the industry-sponsored trial? And we are going to unpack this in the next slide. And industry sponsorship often introduces significant conflict of interest. And this has been well documented in the literature. When researchers conduct trials, write articles, or receive honoraria from pharmaceutical companies, it can even unintentionally bias how studies are designed, conducted, and reported. And Turner and colleagues looked into this, and they found that when a trial has positive results, that means drug or intervention worked, and its publication rate is 98%. But when the results are negative, meaning the drug or intervention did not work, publication rate dropped to 37%. And even those negative studies are published, only 8% of them actually represented as negative. The rest of them usually find a way to blame something else. Maybe the study was underpowered, maybe sample size was too small, maybe there was some technical glitch, anything other than admitting the intervention simply did not work. And we see a similar pattern with liposomal bupivacaine study. In trials where there was a conflict of interest, meaning the study was industry sponsored, 46% showed liposomal bupivacaine as superior. But in trials without any financial conflict, this number drops to just 11%. So it's pretty clear who funds the study can have a major influence on study results. So after publication of this meta-analysis and another study by Dr. Brian Ilfeld, which is identical conclusion, Pacira, the maker of the liposomal bupivacaine, was not exactly thrilled with the findings. They sued ASA and asked for retraction of the article. And their argument? Trade libel. And now trade libel is a legal term. It means intentional disparagement of the quality of a service or product. Basically, they are saying that article hurt their reputation and their bottom line. But now let's step back for a second. Why would a CA3 anesthesia resident, someone who hadn't even officially entered clinical practice yet, be orchestrating some kind of grand conspiracy to intentionally harm a pharmaceutical giant? It doesn't make any sense, right? The district court agreed. They ruled that Pacira failed to state a valid claim for trade libel. Pacira then appealed that decision and lost again. But the story doesn't end here. In October 2023, ASA announced that it had received 2.5 million donation from Pacira to advance education and innovation for our members. And just like that, the conflict seemed to be resolved because, as you all know, sometimes money talks. But sometimes science doesn't change the clinical practice. It can actually move to the stock market. Here is a stock graph of Pacira over time in the last few years. And you see that I marked some key points. Here, publication of the article by Nasir Hussain, which we just discussed, and another article by Dr. Brian Ilfeld, published here. And here, Pacira sued ASA. And after a few months, district court ruling. And after that, you see that stock market, tremor in the stock market, and it is stock value sank by more than 60% from its peak. It's a pretty powerful reminder. Good science and good evidence can have ripple effects far beyond the clinical practice. So, what is the main takeaway from the Taj Mahal study? Liposomal bupivacaine has not demonstrated clear superiority over non-liposomal bupivacaine or ropivacaine for peripheral nerve block analgesia. But is this result surprising? Not at all. When Pacira submitted their application for initial FDA approval, they are not required to show that this liposomal bupivacaine was better than regular bupivacaine. They only had to show that it worked better than a sham control, which basically saline. Of course, any drug contain an intermediate acting local anesthetic is going to be better than saline, right? That's a pretty low bar to clear. And it's something FDA advisory panel actually warned about. In fact, the panel voted 6-4 against expanding liposomal buvivacaine's indication for regional pain control after surgery. But their caution was overruled by the FDA, largely because we are in a middle of opioid epidemic and there was enormous pressure to find opioid sparing alternative, even if the evidence was not ideal. So in a way, it's like being offered the chance of buying a luxury car that doesn't actually drive any faster than your old Toyota Corolla. And the price difference, a vial of liposomal bupivacaine about $334 versus regular bupivacaine, which cost around $3. So now we are in Paris with the iconic Eiffel Tower, one of the most recognized symbol of love and elegance in the world. Completed in 1889, it was originally criticized by some as being eyesore. But over time, it became a masterpiece of engineering. Today, it stands out not just as a symbol of France, but of connection, creativity, and of course, romance. So, well, just as the Eiffel Tower reshaped the Paris skyline, the technique we are about to discuss could reshape our way of thinking of regional anesthesia and postoperative pain management. Under this backdrop of innovation and elegance, let's talk about fascinating study by Brian Ilfeld, which was published in Anesthesiology in 2021. A randomized, sham-controlled pilot study on peripheral nerve stimulation, acute postoperative pain. But before we dive into the evidence, I want to point out peripheral nerve stimulation is not a new concept. It is actually used in the chronic pain world for quite a while. But what's new and exciting is its application for acute postoperative pain management. What made this possible? Mostly the development of miniaturized devices like the one you see here. Technically, placing one of these is very similar to performing a peripheral nerve block. Under ultrasound guidance, you insert a slightly larger bore needle, like 18 gauge or 17 gauge, near the target nerve. And just like you do this for a block, then you pass a tiny electrode through the needle, leave it in place, and remove the needle. And this electrode then connect to a small pulse generator, and in some model, you can even bury the electrode under the skin, close it with a small suture or glue, and control the stimulation wirelessly. So how well does this work? Let's look at some evidence. So this study by Dr. Brian Ilfeld was published in Anesthesiology, a randomized sham-controlled pilot study, which is multi-center prospective study of neuromodulation on pain after ambulatory orthopedic surgery. What authors did preoperatively, they placed electrical electrode to target a specific nerve depending on the surgical site. The sciatic nerve for foot and ankle surgery, femoral nerve for ACL repair, brachial plexus for rotator cuff repair. After the placement, they gave a single injection of long-acting local anesthetic near the same nerve, like we do this for any single shot nerve block. Then, after surgery, patients are randomized to receive either active stimulation or a sham or placebo stimulation for 14 days using this electrical pulse generator that I showed you earlier. Over the first 7 days, patients receiving active stimulation used a median of 5 milligram opioid compared to the 48 milligram in the sham group. That's almost tenfold reduction of the opioid consumption. And in this slide, we see the raw data extrapolated into the raw line graph to visualize opioid consumption in the first 7 days. And as you see that effect of peripheral nerve stimulation, which showed in the red bar, red line, and is robust and sustained for the 7 days. Patients in the active stimulation group consistently used far less opioid compared to those with the sham group. And that gap holds strong across the first postoperative week. So, PNS is a promising new technique for acute postoperative pain management, but more research is still needed. They compare to the conventional continuous nerve catheter, there is some distinct advantage with the PNS. There is no local anesthetic, so no risk of motor blockade or local anesthetic systemic toxicity. No infusion pump needed, no bag changes, no lines to manage. And leads can be left up to 60 days, whereas infusion pump, we only keep it for a few days. So it's a much cleaner setup and potentially a long-lasting solution. Now we shift our view to the Burj Khalifa, standing tall in Dubai as the world's tallest building. It's not just an architectural marvel. It's a symbol of ambition, innovation, and frankly, a little healthy competition, because I have been hearing rumor that Saudi Arabia is now planning make 2 of these towers that surpass it in the next few years. So, but height aside, this Burj Khalifa is remarkable because it integrates residential, commercial, entertainment spaces, a truly multifunctional structure. And under the backdrop of this towering achievement, let's discuss something that has been a tower in our own practice, thoracic epidural analgesia. In my view, this technique, this procedure is Burj Khalifa of regional anesthesia, specifically for the abdominal pain, compared to anything else we do. And we look into 2 important recent articles in British Journal of Anesthesia, which triggered some friendly debate. So let's read the title of this article: Therapeutic Efficacy of Intravenous Lidocaine Infusion Compared to Thoracic Epidural Analgesia in Major Abdominal Surgery, a non-inferiority randomized controlled trial, clinical trial, published in British Journal of Anesthesia. Now let me ask you, how many of you genuinely believe that IV lidocaine infusion could offer the same level of pain control as thoracic epidural analgesia? Please raise your hand. Exactly, absolutely no one. So this was the reaction across the social media too. A total storm of disbelief. People are asking, why would British Journal of Anesthesia even publish this? It just didn't align with most clinicians' real life experience. So, what happened here? How did these two asymmetric interventions, precisely placed thoracic epidural analgesia versus simple lidocaine infusion, end up looking statistically similar in terms of efficacy? Well, here is the one explanation, and this is what my colleague and proposed in our commentary to the British Journal of Anesthesia, which I'll tell you in the next slide. And we think a lot of epidurals, especially those placed without imaging, may not actually be in the right place. So if you combine the effect of failed, suboptimally placed epidural with those that are placed correctly, you are essentially diluting the true efficacy of the technique. That average could make it similar to the effect of IV lidocaine infusion. It's possible. Let's take a look at what we wrote regarding the article. So in our commentary, we say the thoracic epidural failure is common. In fact, studies have shown that failure rate can be as high as 50%, which is staggering, especially considering how central this technique in our perioperative pain management strategies. And honestly, it is not surprising when you think about the technical complexity involved. Among all the procedures we do in regional anesthesia, I think this is probably thoracic epidural probably most challenging. Why? First, it is the extreme chordal angulation of the thoracic spine makes it incredibly difficult for the TUI needle to navigate enter the epidural space. And second, needle can easily deflect to the paravertebral muscles and slip into the wrong plane. LOR has a low specificity because of the anatomical issues, and in some patients, ligamentum flavum is not fused in the midline, which increases the risk of accidental dural puncture. So when you interpret trials comparing thoracic epidural to other modalities, you have to factor the real-world variability and failure because it absolutely affects the outcome. So here, now the obvious question, how can we reduce the thoracic epidural failure? And Kumar and colleagues provided a great summary of some practical techniques that can help improve the success rate. One method that has been particularly effective in our own practice is contrast epidurography. We do the epidural using traditional blind technique preoperatively, like any of you, but after surgery, we inject contrast through the catheter to confirm the placement and take a picture. And if it is not in the right place, we don't just cross our fingers, we pull it and do it again. Sometimes a second or even third time. But we make sure that patient leave the PECU and with a functioning epidural. Of course, this technique does come with some learning curve. Reading contrast epidurogram is not something most regional anesthesiologists are familiar with, and that's where your chronic pain colleagues can be a huge help. By the way, it's definitely the best that we do all thoracic epidural under fluoroscopic guidance from the start. And I know that some institution already started doing that. But this requires access to C-arm, and whether that's feasible depends on your case volume and your workflow logistics. And other techniques like epidural waveform analysis and electrophysiological stimulation look promising, but they are still in early and experimental stages. We need more data before bringing them into clinical routine practice. So bottom line is, Thoracic epidural analgesia is a valuable technique for abdominal and thoracic surgeries, but it is associated with significant failure rate up to 50%. We should keep this in mind. And techniques such as electrophysiological stimulation, waveform analysis, ultrasound guidance, X-ray epidurography can significantly enhance the success rate. On this slide, you see the Statue of Liberty standing tall in Upper New York Bay. Originally, it was conceived as a symbol of deep friendship between France and United States and a celebration of liberty, particularly the abolition of slavery after the US Civil War. But over time, it became so much more. A beacon of hope and opportunity for the millions of immigrants seeking a better life. Now, under the backdrop of this great symbol of freedom, we want to talk a new freedom in perioperative pain management. The arrival of new FDA-approved non-opioid analgesic, one that could expand our option for multimodal pain regimen and help us to liberate from opioid reliance after the surgery. Let's dive into it. The medication we are about to discuss has been over 2 decades in the making. And its origin, its story surprisingly started from Lahore, Pakistan. A group of researchers from United Kingdom are visiting Lahore, Pakistan, and they found that is very remarkable. They found a 10-year-old boy who could walk in the burning coals and push knives through his arms. And yet he shows no sign of pain, no flinching, no distress, nothing. Naturally, this caught their attention. And they did further investigation, genetic studies, and in the Cambridge Institute of Medical Research. Then they published the data in Nature magazine and showing that the boy, that street boy, and several of his relatives has a genetic mutation. This mutation inactivates the gene critical for sensing pain. And this is NAV 1.8 channel and discovery, and which opened up the new target for pain relief and set the drug companies 2 decades of long journey to develop this drug. And here you see that image of a VX548 drug and molecule alongside with the sodium channel, NAV 1.8. This drug blocked the sodium channel, and this sodium channel is highly expressed in the primary afferent neuron. By the way, we do have a lot of sodium channels blocker in the market, but all of them are non-specific. Only thing make this VX548 apart from other sodium channel blocker that is specifically block sodium channel that is expressed in the primary afferent neuron. So unlike opioids, which act broadly on the central nervous system and cause a wide range of side effects, VX548 works right at the target, at the source of pain. That means it has potential for effective pain relief with far fewer systemic side effects. Let's take a look at the clinical trial data behind it. This slide highlights the recent double-blind, randomized and placebo-controlled study published in New England Journal of Medicine, and it's a major milestone for VX548. In this study, as you see here, the patient undergoing abdominoplasty received VX548 after the surgery, and results showed that drug provided significant postoperative pain relief up to 48 hours compared to the placebo. This is a very exciting result, not just because it worked, but because it did so without a typical opioid-related side effect. And BX548 showed almost identical result in patients undergoing bunionectomy. And this consistency across the different procedure, different surgery, makes VX548 a really promising addition to our multimodal pain management toolbox.